Hello everyone, today we are going to solve question number 141, linked list cycle. Given the head of the linked list, determine if the linked list has a cycle in it or not. Return true if there is a cycle in it, otherwise return false. So what a cycle is basically that while traversing this linked list, you reach an already visited element or an already visited node again. Okay, so we can see in this example, we had 3, 2, 4, 0, -4, and we reached 2 again. Okay, so this is an example of cycle, and this is also another example of cycle. So the positions mentioned here are not in use for this question because in this question it just demands us that we have to return true if there's a cycle, else return false. So we don't have to find the entry point of the cycle, rather we just have to find if there is a cycle in this linked list or not. Okay, so let's see the first method to solve this question. So the first method that I'm going to discuss is going to be using an unordered set or an unordered map to store the address of the nodes. Okay, so the key observation in this question will be if we reach back to same linked list node, we have a cycle with us. Okay, this method is going to take a time complexity of O(n) and space complexity of O(n). Space complexity to store an ordered set or an unordered hash map. Okay, the tasks to follow this method is going to be: first we'll have to pick the nodes iteratively. Next we'll put them in an ordered map if they don't exist already. Okay, if they do exist, that means we already have a cycle. Okay, because linked list here is linear, and if we reach the same element again, this means we have a loop with us. Okay, so it's going to look like this, where node star is the address of the nodes, and bool is just marking them if they already exist or not. Okay, so we'll start from here where okay, so we'll start from here. We'll have a pointer this point. Okay, now we'll traverse it. So we'll have this for first iteration, this will mark this true. For the second iteration, this will mark 2 true, this will mark 3, this will mark 4, this will mark 5, and after this we'll reach back to 2 again. Okay, we'll reach back to 2 again, and at this point we'll have this rule applied with us, the rule number 3, where if the current node exists already, we have a cycle. Okay, so let's code this one. So basically we'll need an unordered map list node star comma bool. Okay, and I'm going to name it as visited. Okay, now we'll also need a pointer to traverse over this linked list. So list node star temp is equal to head. Okay, now I'm going to write the traversal part where while temp is not equal to null. First, we'll have two parts here. First, if visited of, and we're going to find our temp, find temp is not equal to mp dot, or you can say visited dot end. Okay, this means already existing case. This one is already existing. Okay, so in that case we'll have our answer as return true, because this means we have a cycle with us. And the other cases will be, first is going to be marking part, so visited of temp is equal to true. Okay, and other part is going to be temp is equal to temps next, so basically moving a pointer to the next node. Okay, so that should do it, and in the end we have to return false if everything goes right. That means we have a complete linked list with us without any loops. So false. That's so let's run this. Okay, so let's submit this. So this is going to be first method, which is basically using an unordered map. So this method is having a time complexity of O of n and space complexity of O of n as well. Okay, so let's see the second method to solve this question. Now we are going to discuss the second method to solve this question. So in this method, what we are going to do is we are going to optimize this time complexity of O of n, but obviously we cannot because we have to traverse this loop at least once to find if there is a cycle in it. Rather, we are going to optimize this space complexity of O of n. So rather than using an unordered map, we are going to use something else. Let's see what. Okay. So basically, the main question arises that can we do some space optimization? Okay. This method is going to have a time complexity of O of n and space complexity of O of 1. Yes. And how we can do that is using 2 pointers. Okay. So basically, this is a previously discussed method in my last video where we discussed a fast and slow pointer. Okay. So the main philosophy behind this method is going to be there's a tortoise and there's a hare. This hare, or you can say fast pointer, moves at twice speed of this tortoise. So if there's a loop that exists inside this linked list, in that case there will be a point where this tortoise and hare will meet again other than this starting point. Okay, that's the simple intuition behind this. So the tasks in this to follow this method is going to be start traversal over the list using slow and fast pointers. If slow and fast reach at same node, then the cycle exists. If not, that means the fast might have reached the end of the list, which is going to be obviously null, and hence there's no cycle present inside our linked list. Okay, so let's see how this method works. Let me show you. First, what will happen is there'll be this here. We have initialized them to head. This here is going to move to 2 steps, and the starter is going to move to 1 step. Next iteration, this here is going to move to 2 steps. The starter is going to move to 1 step. For the next iteration, this here is going to use this loop to move to this point, and Tortoise is going to move to 1 point. Okay. After this iteration, we'll have here which is going to move to 2 iterations, and Tortoise is going to move to first iteration. And you can see here in this case we have the case where both of them met with each other. Okay, so in this case we'll return answer that yes, there's a loop that exists because tortoise will never be able to catch hare, but in this case it's possible, hence we have proved that there's a loop in this linked list. Okay, so let's code this one. So first we'll need 2 pointers. So list node star, I'll name it at here, is equal to head, and list node star tortoise is equal to head. You can also use fast and slow, it's just same. While here is not equal to null, and here's next is not equal to null. So this is very standard approach to write where fast is not equal to null and fast next is not equal to null. Okay, so what we are going to do is we are going to move them tortoise by 1 point, means one node, and here by two nodes. Okay, so tortoise is equal to tortoise next, here is equal to here's next. Okay, so this is going to be part, and this is our base main logic to solve this question, where if tortoise equal here. Okay, in that case scenario we can return true. That means a loop exists. Okay, and after all iterations, if we don't have that case, then we can safely return false. So let's run this. I might have some spelling mistakes, but I don't think so. Okay, let's submit this. So that's it for the second method. This method is going to take a time complexity of O of n and space complexity of O of 1. Okay, so now let's discuss the third method, which is almost the same. Okay, let's discuss it.